y double dash minus 3y dash plus 4 equals 3x, and we got these initial conditions. So let's do for yh to start with then. So here we can simply write y double dashed minus 3y dashed plus 4y equals 0. This gives us the associated quadratic equation lambda squared minus 3 lambda plus 4 equals 0, and that tells us that we can factorize that lambda minus 3 and minus 1, isn't it? Lambda minus 1. So that implies lambda, two distinct roots, 1 and 3. So this is case 1 gives. So we got y equals then yh a e to the first one, which is 1, plus b e to the power of the second one, 3x. That's yh done then. In the problem now we turn our attention to yp. We've got 3x, so we go down to our table and we try ax plus b, don't we? So let's try y equals ax plus b. So then if we have that, we have y dashed is equal to a, isn't it? And y double dashed is equal to 0. So substitution now gives, so we got y double dashed here, so 0, minus 3y dashed, which is a, from there, plus 4y plus 4, ax plus b is equal to 3x. So we've got the x's, so let's equate those coefficients. 4ax equals 3, so that tells us a is equal to 3/4. So a equals 3/4. So there's a. And if we equate the constants, minus 3a here, 4 times b is plus 4b, and the constants on the other side is 0. So that tells us then that b, 4b, is equal to 3a, which equals 3 lots of 3/4, which is 9/4. So that tells us then that b is equal to, divide by 4, 9/16. So that's b, lowercase b. So we can write down the particular solution then. Yp is equal to ax plus b. So a was 3/4 plus b, which is 9/16. There we go. So that's the yp part of the problem done. Now we can write down the general solution. So the general solution yh, which is here, a e to the x plus b e to the 3x plus the yp 3/4 x plus 9/16. So there's our general solution. Now we can differentiate and we'll get the y dashed here. So the e to the x is just a e to the x. The 3 comes down to b with the b, doesn't it? Plus 3b e to the 3x. Then the x goes to 1 and it's 3/4. And the constant goes to nothing. So there's y dashed. Let's invoke our initial conditions then. Here they are here. Y dash naught is 0 and y naught is 2. So y naught is 2 can go in first if we wish. Y naught equals 2 then. Here. So when x is 0, y is 2. So that gives 2 equals a e to the 0 is a, b e to the 0 is plus b, x is 0 plus 9/16. So that tells us that capital A plus b then. 2 as 16ths is 32/16, take 9 is 23/16. 32 take 9 is 23, so that's 23/16. So there's equation 1. Now the other initial condition, y dash 0 was equal to 0. Let's just double check that we remember. Y dash 0 equals 0, yeah, that's fine. So y dashed is here, that equals 0, is equal to a e to the 0 plus 3b e to the 0 plus 3/4. That tells us then that a plus 3b is equal to, move the 3/4 over to minus 3/4. And we can write that as 16ths, can't we? Because that'll make it a bit easier. So that's 12/16, isn't it? Times top and 3/4 top and bottom by 4. So that's equation 2. 2 take 1 then? Take away 1. What does that give? That take that as 2b is equal to minus 12 take 23 is minus 35/16. So b is equal to then is equal to minus 35 over the 32. There's b, capital B. So a equals then, let's get it here, 23/16 minus the b, because we're moving the b over, and that's minus, so that's plus 35 over 32. So we're dealing with fractions with the denominator 32, so double top and bottom is 46 over 32 plus 35. 46 plus 35 is 70, 81. 81 over 35. So a equals then 81 over 35. There we go. So now we can write down the particular solution. So y equals, here it is here, 81 over 35 e to the x plus b, which is minus 35 over 32 e to the 3x plus 3/4 x plus 9/16.